And now, folks, it's time for multi-step equations. Everything that we've learned up to this point, when we talked about combining like terms, distributive property, even going back to solving one-step and two-step equations, we're going to use all of those skills for multi-step equations. So make sure you have your composition book out with your foldable and ready to go. So if you open up both tabs of your foldable that say Steps for Solving, I spread them out all the way across. When you are going to solve a multi-step equation, the first thing you look for is if there's any distributive property. If there is distributive property, you must do that first. After you've done your distributive property, then you look to see if there's any like terms that you need to combine on each side of the equation. So you'll look on the left side of the equation and see if you can simplify the left side of the equation by combining like terms. Then you go to the right side of the equation, see if there's any terms that you can combine over there. After you've combined your like terms, then you get all the terms with variables on one side of the equation. After you've gotten all the terms with variables on one side, then you have to get all the terms that are just constants on the other side of the equation together. Once you've done this, you should end up with a one-step equation, so of course now you would have to do the inverse operation to get the variable alone. And I know all these words don't mean anything, so let's jump in and solve some problems so you can see exactly what I'm talking about. Open up your tab that says One Solution. We're going to solve some multi-step equations that have one solution. So if we look at this here, we look to see if there's any distributive property. Yes, there is. We have this -3 that we're going to have to distribute with our p and our -4. But first, we bring down our 8. Now we say a -3 times p is going to give us a -3p. A -3 times a -4 gives us a +12, and that is equal to our 7p. Now we look on the left side of our equation. Is there anything that we can combine? Do we have any like terms? Well, I happen to see the 8 and the 12. So we would have a -3p plus 20 equals 7p. Now we've got to get all of the terms that have a variable on one side of the equation. So I'm going to move the -3p over to the right side. I'm going to get all the p's on the right side. So we're going to add 3p to both sides. Now when we do this, this becomes 0. We're left with 20 on the left-hand side of the equation and 10p on the right. Now to get p by itself, that's 10 times p, so we divide by 10 on both sides, and now we get that p equals 2. That's the only solution this equation has. Now for our next example. This one's a little bit larger, and I think I kind of made a mistake on this by looking at what I've written here. I accidentally typed in an equal sign when this should be a plus sign. I apologize. Alright, so again, first thing we do is we look to see if we have any distributive property. So we have this 6 outside of the parentheses, so we say 6 times 6c, which would give us 36c. Then we have 6 times -2, which would give us -12. Now we have to take this 8, this +8, and we have to distribute it with every term inside of this set of parentheses. So now we have +8 minus 40c equals a -2c. Next, we look to see if there are any like terms. Well, I see 36c and -40c. 36 and -40 would give us a 4c. Then I also see negative 12 and 8. Negative 12 plus 8 is going to give us a negative 4. And that is equal to a negative 2c. Now we have to get all of our terms with variables on one side of the equation. So I'm going to add 4c to both sides. When I do this, you can see that this becomes 0. We're left with negative 4 on the left-hand side, and then we have 2c on the right-hand side. Now we've got to get c by itself. We've got to get the variable all by itself. So we do the inverse operation, which means we are dividing by 2. So now c is equal to a negative 2. And that's our last example for one solution. Now let's move on. Here is our first example for no solution. If you look at this, we have 5 plus 2x equals 2x plus 6. Is there any distributive property here? No. Can we combine any like terms when we look on the left side of the equation? No. Can we combine any like terms when we look on the right side of the equation? No. Therefore, we have to get our terms with variables, on one side of the equation together. So I'm going to subtract 2x from both sides. When I do this, on the left-hand side, I'm left with 5 because positive 2 and negative 2 cancel. On the right-hand side, I am left with 6. Does 5 equal 6? 5 does not equal 6. Therefore, there is no solution. Sometimes the way that you will see no solution written is this right here. Sometimes that's used for no solution, or it could also mean empty set. So you need to know that symbol as well. Now on to our second example. So again, your second example is a little more difficult. If we look on the left side of our equation, we do have distributive property. So we have to bring down the 8x because it's not right next to the parentheses. Now we take 4 times 4x, which gives us 16x. Then we take 4 times negative 3, which is going to give us a negative 12. Over on the right hand side of the equation, we also have distributive property. So we say 4 times 6x, which gives us 24x. And then 4 times 4 gives us 16. And then don't forget about the minus 4 at the end. It has to come down. Now we look on the left-hand side to see if we have any like terms. Well, I see 8x and 16x. 8x and 16x is going to give us 24x. And then we have minus 12 equals, then over here on the right-hand side, I see some like terms. We have a positive 16 and a negative 4, which is now going to give us plus 12. So now we have to get our terms with variables on one side of the equation. So I'm going to subtract 24x from both sides. When I do that, I am left with a negative 12 equals a positive 12. Does negative 12 equal a positive 12? No, they are two different numbers. Therefore, this is no solution. So now we've talked about one solution, no solution. Let's go to infinite solutions. So the first problem, of course, I give you an easy one first, and then we move to the more difficult one second. Here we got to see if there's any distributive property. And yes, there is. We have 2 times x, which is 2x, and 2 times 3, which is 6. And then over here on the left we also have 2x plus 6. So next we've got to get our terms with variables on one side of the equation. I'm going to subtract 2x from both sides. When I subtract 2x from both sides, I'm left with 6 equals 6. Is this a true statement? Does 6 equal 6? Yes, it does. Therefore, this is going to be infinite solutions. Now, could I have stopped before going through and solving? Yes. I could have stopped right here when I saw that I had an equation set up equal to the same equation. You see how the expression is the same on both sides of the equal sign? That means that it's going to be infinite solutions, because no matter what number you put in for x, it's always going to come out the same number on each side. That's why it's called infinite solutions. And now here's our more challenging problem that requires us to do a little more work. First, we check for distributive property, and I see that there is distributive property on both sides of the equation. We bring our negative 5m down because it is not right next to the parentheses. So here we have 3 times m, which is going to give us 3m. And then we have 3 times negative 5, which is going to give us a negative 15. Over on the right hand side, you say, well, there's nothing to do distributive property with. Remember, I told you that when you have a negative sign sitting right outside of the parentheses, that's like there's an imaginary 1 there. So we have to distribute a negative 1 with each term inside, which basically all that does is change the sign of each term inside. So it goes from 2m to negative 2m, and it goes from positive 15 to negative 15. That's all a negative 1 does. So now we have to look to see if we can combine like terms. If you look on the left hand side, you see that there is a negative 5m and a positive 3m. So this is a negative 2m minus 15 equals a negative 2m minus 15. What do you notice on each side of the equal sign? We have the same exact expression. Therefore, this is going to be infinite solutions. So now let's go and take this to the next level of a real-world problem. If we have the problem, Perfect Printing Company will print business cards for 10 cents each, plus a setup charge of $15. Printing Express will print cards for 15 cents each, with a setup charge of $10. What number of cards cost the same from either company? So first, let's identify what our variable is going to be. We're going to use n, and n is going to represent the number of cards, because that is our unknown. Okay, if we look at the first part of our problem, it says that Perfect Printing Company charges 10 cents each. That means 10 cents per card. So therefore we would say 0.10 for 10 cents, and that would be n, plus a setup charge of $15. Now it says Printing Express will print cards for 15 cents each. So that's 15 cents n, with a setup charge of $10, so plus 10. It says what number of cards cost the same. When it says the same, that means when they are equal to each other. We've got to find out what n's going to be for them to be equal. So now here we have a multi-step equation. Do we have any distributive property? No, we do not. Do we have anything that we can combine like terms on either side? No, we do not. So all we can do here is get all of our terms with variables on one side. I am going to choose to move the 10 cents in. That way it keeps my coefficient of n a positive. So this is going to be 15 equals 15 cents minus 10 cents is going to give us 5 cents n plus 10. Now we subtract 10 from both sides. And so we have, let me move this up, I'm running out of room here. We'll go down to some white space. So now we have 5 equals 5 cents n. So now we've got to find out how many cards at 5 cents a piece will be $5. So we're going to divide both sides by 5 cents. And 5 divided by 5 cents is 100. So if you purchase 100 cards, it's going to cost the same at either company. The question wanted to know how many cards would it be so that the cost would be the same with each company. So there's your real-world example to kind of get an idea of what the problems sound like and look like. So tomorrow we're going to practice multi-step equations in a fun kind of way. So we'll see you tomorrow.